Okay, we're going to do all the got it's on one video again. We're going to practice long division one more time. So we have our big polynomial 3x squared minus 29x plus 56, and they need us to divide that by x minus 7. Now, one thing to make a special note of is to be very careful with your signs. So the question becomes, what does x need to become 3x squared? So I need a 3 and another x. Now I backwards distribute. 3x times x is 3x squared, and 3x times negative 7 is minus 21x. Something very important to remember here, and I always use a different pencil or something, is to change these signs to make sure you get it right. The reason we change our signs is just like normal old school division, so those cancel out, and you end up getting a negative 8x, because negative 29 plus 21. And you bring down your 56. Next we ask ourselves, what does x need to become negative 8x? It needs a minus 8. So I backwards distribute, and I get negative 8x plus 56. And again, something very important to remember, change those signs. And what ends up happening in this problem is everything cancels, and I don't have a remainder because everything cancels to 0. So my answer is, or I should say my quotient, my answer is my quotient is 3x minus 8, and if you want to tell me that the remainder is 0, you certainly can do that. Let's move on to got it number 2. Got it number 2 asks the question, is x to the 4th minus 1 a factor of this polynomial? If it is, write it as the product of two factors. So if you need some practice, go back and take a look over here, and now we'll just apply that on this side. So we take our polynomial, flip mine over, and if we're missing anything, remember we need to put in a 0. So I'm going to do x to the 5th plus 5x to the 4th. Oh, I don't have an x to the 3rd, so I have to remember put 0x to the 3rd. And again, I don't have x squared, so I gotta put 0x squared, and then minus x, and then minus 5. That's what you have to do this in synthetic too, so if you're missing something, remember to put it in a 0. And then they want us to divide that by x to the 4th minus 1. I don't find it really essential to do the zeros on the outside because I just put it where it belongs corresponding, and I'll show you what I mean. So what does x to the 4th need to be x to the 5th? Well, it just needs an x, doesn't it? Backwards distribute. So x to the 4th times x is x to the 5th. X times negative 1 is minus x. Now watch where I'm going to put that. Way over here. Okay? You just put it where it belongs whenever you multiply it. So you draw your line, change your signs, and let's see what we get. So, sorry, when I change that sign, it's negative, not positive. Alright, sorry. Change that sign, it's a big old negative. So these cancel, boom, boom. And I have 5x to the 4th left. I have 0x to the 3rd left. I have 0x squared left. Oh, look at that. Even my x's cancel out, so I'm going to have a 0x left and a minus 5. Now what I do is I bring down, I ask myself, what does x to the 4th need to become 5x to the 4th? It needs just a 5. So I'm going to bring that down. So I get 5x to the 4th minus 5. And that goes all the way over here. Change your signs. And in this one, it's almost kind of like a special case. See it? These cancel out. I end up with every single item as a 0. Now, does that always happen? Absolutely not. That does not always happen. But see how they're all zeros? That means there's nothing left. So if there's nothing left, that means my remainder is 0. So let's use some logic here, okay? Since my remainder equals 0, x to the 4th minus 1 is a factor. And that is again because my remainder is 0. So they said if it is, write it as the product of two factors. So the product would be x to the 4th minus 1, which was what they asked about, times what I got as my answer, x plus 5. And that's it. Part B. Using the fact that 12 times 31 equals 372, is there a way that you can write 3x squared plus 7 plus 2 as the product of two factors? Well, I don't know if they're trying to make this more confusing or not, but here's how it works, okay? So you get 12 times 31, and that equals 372. All you need to understand is that 372 is 372 here. And because 12 times 31 is 372, and this is 372, they're saying this. You can factor it as such. A double parenthesis using 12 and 31. You can take the 1 here and make it 1x. You can take the 2 here and make it 2. You can take the 3 here and make it 3x. And the 1 here and make it 1. And then these are both pluses. And that, if you did FOIL that together, you would get that 3, you would get the 7, and you would get the 2. Okay? Honest, if you can factor, you can factor. If you can divide, you can divide. Let's move on to problem 3. Now problem 3 is when things start speeding up because we have synthetic division. And synthetic division goes pretty gosh darn fast. And as you can see, I already did the got it for problem number 3 with you. And those are really nice, aren't they? Just remember that if there's nothing there, like if there's not an x squared, you need your 0. But synthetic division is really nice. As long as you can multiply and add, you'll be good to go. So we're going to go all the way to got it number 4. Okay? And let's read it over. In got it number 4, they say, we have this polynomial, x cubed plus 6x squared plus 11x plus 6, and it expresses the volume, okay, so this polynomial is the volume of a shadow box. We know that the width is x plus 1. What are the dimensions of the box? Well, if we know that x plus 1 is part of it, we can figure out the other parts. So I have to use -1 in my synthetic division. You use the opposite of what you see. So I'm going to type in -1, put it in your little synthetic box, or whatever you want to call it, and put down the coefficients of your polynomial. 1, 6, 11, and 6. 1, 6, 11, and 6. Now synthetic division, ready to practice? Drop this down 1. Multiply, -1. Add, 5. Multiply, -5. Add, 6. Multiply, -6. Add, 0. That was a lot easier than long division, wasn't it? Now work your way backwards. This is your constant, so it would be plus 6. This is your x, so it would be plus 5x. This is your x squared, so it's x squared. Now in terms of this problem, they want what are the dimensions of the box. Well, you guys all know this, right? We learned this, I'm not sure when. Volume equals length times width times height. So they already told us that the width is x plus 1. So here's what we have so far. We know that the width was x plus 1. That implies that what we got, x squared plus 5x plus 6, incorporates the other two. So this parenthesis they told us is the width. This parenthesis, therefore, is the length and the height. So what we need to do is break this polynomial down. And guess what, guys? This is an easy factoring, isn't it? X plus 2, x plus 3. And you can bring down that x plus 1 again. But there you go. You have your 3 separate dimensions. You have your width, you have your length, and you have your height. And that is all they wanted, the different dimensions. Moving on to got it number 5. All the way at the bottom. Looks like I already kind of told you that in got it number 5 you're going to start with, well, let's go ahead and read what it says. we have a polynomial. We have that that they want us to figure out what is p of negative 4. Now remember, another way of doing this is you could just plug in negative 4, right? You could just plug that thing in and get your answer. But the new thing today is that if you like synthetic division, if you want to use synthetic division, the remainder is the answer as well. So you could plug in negative 4, get an answer, or you can use synthetic division, and the remainder, whatever you get at the end, that's also what you would get if you plugged in negative 4. So you put negative 4 in your little box, and we just write the coefficients. So we do, let's see, we know it's 1, 3, 1, negative 3, negative 28. Oh, there's no x squared. So you have to use 0 for x squared, 5 and 20. 1, negative 3, negative 28, 0, 5, and 20. Nice long problem here. Now let's use synthetic division. Carry down the 1. Now it might help for you to watch this and then to rewind and play it again, just so you can kind of follow my arrows. Multiply, negative 4, add, negative 7. Multiply, positive 28, add, 0. Problem is, if you screw up one sign, we're in trouble. Multiply, 0, add, 0. Multiply, 0, add, 5. Multiply, negative 20, add, 0. See how you get a remainder of 0? That means that if you took your polynomial and you plugged in negative 4, you would get 0 as an answer, because your remainder is 0. Maybe you should put that on there. Because your remainder equals 0. Now, if you don't want to watch this, you don't really have to, but I want to show you that that is in fact the case here. I want to show you on your calculator how you can get the same thing as if what we just did. Alright? So we're going to take x to the 5th. Instead of x, we use negative 4 to the 5th. And then we do minus 3. And we put it in negative 4 to the 4th. And right here, minus 28. Negative 4 to the 3rd. Right here, plus 5 times negative 4. And at the very end, plus 20. Now when I hit enter, I should get 0. And that's exactly what the remainder was, so it's exactly what I should have gotten.